Alright, this is the start of video 2, starting with problem 8 on your Unit 9 PreCal review for polynomials. Write the polynomial function that contains the point 0, negative 128 and produces the graph shown below. So it's a little difficult to see here, but our graph is just here, and it has a minimum down here, and then it goes up, and maximum comes down, bounces there. So that's what it looks like. The graph, the calculator window is actually cut off there, but what we want to take from this is we have a single root right there, single there, we have a single here, we have a double root right there. So from that we get f of x is equal to the stretch factor, which we will have to solve for. Now we can start writing our factors from the x-intercepts here. So single root at negative 2, that gives me a factor of x plus 2 to the first power because it's a single root, slices through, that's how I know it's a single root. Single root here at positive 2 slices through, so that factor would be opposite sign, so negative 2, x minus 2 there. We have a double at 1, 2, 3, 4, so a double at positive 4 gives me a factor of x minus 4 quantity squared. I know it's a double root because it's bouncing off of the x-axis there. It's a double root, so I'll raise it to the second power. So now we can substitute in the point that we were given. So 0 is going here, here, and here, and then we'll put the negative 128 right there and solve for a. Same thing we did in the last problem. So negative 128 is equal to the a value times 0 plus 2, 0 minus 2, 0 minus 4 quantity squared. So work that out. Negative 128 equals a times 2 times negative 2. And then negative 4 squared would be 16. So continuing to break that down, we have negative 4, I'll do it this way. 16 times negative 2, negative 32 times 2, negative 64. So divide by negative 64. And after all of that, we have an a value of positive 2. So now I'll rewrite this function and just replace the a value with positive 2. So my final answer up here, f of x is equal to 2 times the quantity x plus 2 times the quantity x minus 2 times x minus 4 quantity squared. And that is our final answer for number 8. Alright, problem 9. Use long division to show that x plus 2 is the factor of f of x equals 2x cubed plus 3x squared minus 8x minus 12, and then completely factor f of x. So technically we could use synthetic division, but they ask us to use long division, so we'll stick with that. Remember, long division always works. Synthetic division only works when your leading coefficient here is 1. So we'll go with long division. So x plus 2 and 2x cubed plus 3x squared minus 8x minus 12. So what times x gives me 2x cubed? That would be a 2x squared here. So I'll multiply that. 2x squared times x, 2x cubed. Then 2x squared times 2 is plus 4x squared. With long division, we always subtract, so these will cancel. That's what I wanted. That flips to a subtraction. 3x squared minus 4x squared, negative 1x squared. Bring down the next term. Repeat that process. So what times x gives me negative x squared? That would be a minus x. So negative x squared there. 2 times negative x is negative 2x. Flip that to a plus. These would cancel. Negative 8x plus 2x, negative 6x. Bring down the next term. Minus 12. Repeat the process. What times x would give me negative 6x? Subtract 6x. Whoops. Subtract 6. Negative 6x. Negative 6 times 2. Negative 12. Cancels. This flips to a plus and also cancels. Remainder is 0. So that proves that x plus 2 is a factor of this original cubic polynomial here. So far we have it factored this way. X plus 2 times 2x squared minus x minus 6. So we still need to completely factor that. Trinomial. Leading coefficient's bigger than 1, so we'll use swing and divide. That's what we've been using. So we'll stick with that. So we swing the 2 over here. rewrite it as x squared minus x minus 12. We multiply the 2 times the negative 6 to get this negative 12. We multiplied by this 2 in the beginning, so we have to remember to divide by it in the end. So now we take this trinomial, factor it as we normally would. We set up our parentheses. We know x here, and we want two numbers that would multiply to negative 12 and add to negative 1. So that would be a subtract 4 and a plus 3. So x minus 4, x plus 3. Then we divide those by the original 2 that we swung over in the beginning. Swing and divide, that's the name. We swung the 2 over, now we divide by it. So that would be a factor of x minus 2. And then we have x plus 3 halves. We'll fix that fraction by multiplying everything in the parentheses, in this parentheses, by 2. Shortcut is you just bring that 2 up in front of the x. Either way, you're going to end with a factor of 2x plus 3. So now we have this function, f of x, fully factored. That would be the original x plus 2 that we identified times the x minus 2 we just found times the 2x plus 3 that we just found. So altogether, x plus 2, x minus 2, 2x plus 3. And that's it for problem 9. Okay, problem 10 says, determine k so that x minus 5 is a factor of x squared minus 15x plus k. So we'll do long division to do that. That's how we prove that that would be a factor. We divide and get a remainder of 0. That's the goal. So x minus 5. So what times x gives me x squared? That would be x. X times x gives me this x squared right here. X times negative 5 gives me the subtract 5x here. We always subtract with long division. Those cancel. That's what we want. This would flip to a plus. Negative 15x plus 5x and negative 10x. Bring down the next term, which in this case is a k. What times x would give me negative 10x? That would be a subtract 10. So negative 10x there. And negative 10 times negative 50 would be a positive 50. And with long division, we always have to subtract and switch the signs, so those cancel. This flips to a subtraction. So for k, in other words, what minus 50 would give me a remainder of 0? Well, that would be 50. So k must equal 50 in order for x minus 5 to be a factor of that polynomial.